we're going to start with the ray box again. So we have 3 rays of light which come out of the ray box. They come here, and they're going to hit this piece of plastic. But if you look at the shape of this piece of plastic, it's got curved edges. It's thick in the center, and it's thin at the edges. So the edges work like prisms to bend the ray of light, but the angle of the prism continuously changes. As a consequence, if I bring this down and put it in the path of the rays, we can see that the rays of light come together at what we call a focus. So the rays of light come in, they hit the lens, and then they're bent. The ray that's on this side is bent closer to the central axis. This one is also bent closer to the central axis. And they come together right here. And we're going to call that the focal point. And we can use this distance from the lens to the focal point, which we call the focal length f. We can use this distance to characterize a lens. We can characterize them by their focal length. So a lens of this shape brings the rays of light together, but we'll also consider a lens of this shape right here. This one is thin in the center, but it's thick on the outside. And when I take this and put it in the path of the rays, we want you to think, how is it going to bend the rays of light? We'll give you some choices. Well, this lens has a different shape, and it brings the rays of light not together, but it spreads them apart. This lens we're going to call a diverging lens. This one right here we call a converging lens. So this one spreads them apart. This one brings them back together. Diverging plus converging, I end up with my rays parallel again. But this is a diverging lens. Now, this lens right here is a converging lens. It brings the rays of light together, and I can tell that because it brings the light of the light we're using to light the studio. It brings it to a focus right here. So this is a converging lens. It's bringing rays of light together, and we can see that. It's thick in the center, it's thin on the edges. And we can use this to make an image. And I'm going to make an image of a light source that we have right over here. So I'll take my lens and place it right here. And I'll take a screen and place it right here. And if the lens is at the right position, we get a sharp image of the object on this screen. This is the object. This is the image. Now, notice a couple of things. First off, this image is an inverted version of the object. And also, the image is small compared to the object. So it's inverted and it's smaller. There's a relationship that we'll learn in the chapter between the distance from the object to the lens, which we'll call S, and the distance from the lens to the image, which we call S prime. So think about this axis that we have, S and S prime. And there's a relationship between S, S prime, and F that looks like this. And I only get a crisp image when those 3 variables are matched. Now the focal point of the lens is fixed. So if I take the lens and move it to a different place, the relationship that held true between S and S prime doesn't hold anymore. It doesn't hold anymore. And so my image is not in focus. There's only one position that will make it work. Now, here's a question. Take a look at the relationship between S and S prime and F, the focal length of the lens. The focal length of the lens is fixed. If I take the object and I move the object closer to the lens, S gets smaller. And you can see what happens is this. The image is now out of focus. How do I have to move the box in order to bring that image back into focus? And I have a couple of options. I could make this distance S prime bigger by moving it farther away, or I could make S prime smaller by moving it closer. Which is the right choice? We'll give you some choices. If we look at the relationship, 1 over F is equal to 1 over S plus 1 over S prime. So if S gets smaller, in order to have the same correspondence, I have to have S prime get bigger. I've got to move the screen farther away. And if I do that, the image is back in focus. Now notice this. The image is now bigger. And I can continue this trend. If I move the object closer to the lens, move the image further back, object closer, further back, I can get things back in a nice crisp focus. And now it's starting to get so large I can't fit it on the screen anymore. It's magnified. And we'll see in the chapter a relationship for magnification, and it depends upon the relationship between this distance s and the distance s prime. And the magnification is a relationship between this distance s and the distance s prime. And the bigger s prime is, the smaller s is, the bigger the magnification is. Now in chapter 18, we look at the basic lens equation and how you use lenses to make images. But in chapter 19, we'll explore how you use lenses to make practical optical devices, cameras, telescopes, and most importantly, the human eye. We'll do that in the next chapter.